We will going to take a look at chapter 2, section 3 with this video. So chapter 2, section 3 is called Measures of Central Tendency. And then with this lesson, we have 3 objectives. We're going to learn how to find mean, median, and mode of a population and the sample. And we're going to find the weighted mean of a data set and how to estimate the sample mean of the group data. And then we're going to describe the shape of a distribution as symmetric, uniform, or skewed, and how to compare the mean and median for each. Measures of central tendency. So what we mean is it's a value that represents a typical or central entry of a data set. So these are very common terminology in statistics class. Mean, median, and mode are three famous vocabulary in statistics class. Mean, in another word, it is average. And how you find the mean of a sample or population, you're going to add all the data entries. So you're going to find the sum of all data entries, and you will divide them by the number of entries. Sigma stands for sum. Sigma notation, this means just add all the data entries. So sigma represents the sum. And then in order to find the population mean, you're going to find the sum of the data entries by the population size for the sample mean. And sample mean represents the X bar, and population mean is mu. So the symbol for population mean is mu, and sample for the notation for the sample mean is X bars. But both of them, you're just going to add all the data entries, and you're going to divide how many entries you have. And this is how you find the mean. If you look at an example, the weights in pounds for a sample of adults before starting a weight loss study are listed. What is the mean weight of the adults? So we have 1, 2, 3, 4, 5, 6, 7 data entries here, and this is a sample. So in order to find the mean, because they're asking for mean, all you have to do is add these numbers and divide them by 7. So that's what they're doing here. So first, they're finding the sum of the weights, which you can show as sigma of x, sum of the weights. And they're adding these 7 data entries, and this is the sum for all these weights. And then you're going to divide it by the number of adults in the sample, and they have 7 adults or 7 entries here. They're dividing the sum by 7, and this is called the mean of the weight, mean weight of the adults. Next vocabulary we're going to look at is median. Median means the value that lies in the middle of the data when the data set is ordered. So the word is ordered here, highlighted, because in order to find the median, if your data set is not ordered from smallest to greatest, your first job has to be ordering them from smallest to greatest. Measures the center of an ordered data set by dividing into 2 equal parts. And then if the data set has an odd number of entries, then the median is the middle data. But if you have even number of the entries in the middle, then you're going to take the average of those 2 numbers. That's how you find the median. So the important points for median is you have to make sure that your data set is ordered from smallest to greatest first. And then if you have just one number in the middle, you're lucky that number is your median number. But if you have 2 numbers in the middle of the data set, you're going to take the average of those 2 numbers. Here's an example. So the question is find the median of the weight listed in the first example. So when we look at this data set, first question we need to ask ourselves is this ordered from smallest to greatest? It is not. So before we find the answer, first we're going to have to order them from smallest number to the greatest number. So that's the first step. And then you just have to find the middle number. And then the middle number here is 268. Since there are 7 entries here, the middle number is just one number because this is total odd number. The middle number is just one number, and that's the median here in this question. And then if you look at another example for finding the median, they just take away one number from the set to make it 6 entries instead of 7. Now, when you look at this question, in the middle now, you have 2 numbers. So in order to find the median now, you have to add these two numbers in the middle and divide them by 2. So basically, you're taking the average of these two numbers to find your median. And then your median is an answer now, which is not listed in the list. Now, the next thing we're going to look at is called mode. Mode is the data entry that occurs with the greatest frequency. If no entry is repeated, the data set has no mode. If two entries occur with the same greatest frequency, each entry is a mode, bimodal. So it is possible that you might have more than one mode in a data set. So we're going to find the mode for this example. So we need to first think how many times each number is repeating. So 223, I see just one time showing up. 235, I see it 2 times. So far, this is the number which repeats more than once. 268 just shows up once. 274 just shows up one. And these two numbers are showing up just one time. So the only number shows up more than one time is 235. So 235 shows up twice, and every other number is showing up just once. Therefore, the mode of this data is 235. Okay, and now there's another example we're going to look at about finding the mode. At a political debate, a sample of audience members was asked to name the political party to which they belong. The responses are shown in the table. What is the mode of the responses? So we have this political party, and this many people said that they're supporting this political party. We have 46 Democrat, 34 Republican, 39 Independent, and 5, they said, I don't know. So when we look at this, which one shows up the most? We're going to say that we have more people declaring Democrats as a political party. So therefore, the mode it will be here the Democrat Party. Comparing the mean, median, and mode. All three measures describe a typical entry of a data set. Advantage of using the mean. The mean is reliable measure because it takes into account every entry of a data set. Yeah. Disadvantage of using the mean is greatly affected by outliers, which is a data entry that is far removed from the other entries in the data set. So it's good that we're using mean when we are thinking about a calculation because mean puts into consideration every data entry. But if there is a very different number than the rest of the data set, it will affect your mean a lot. So when we look at this table, the table shows the sample ages of students in a class. Find the mean, median, and mode of these ages. Are there any outliers? Which measure of central tendency best describes the typical entry of this data set? So when we look at here, if this is the ages in a class, we have a lot of 20 years old students. I have 20, 20, 20. A lot of people answered their age is 20. I have some 21 years old, some 22 years old, some 23, and two 24 years olds. But then this number here, 65, this is the only number which is not among the 20s. So this number is an outlier here. So we're gonna now calculate the mean, median, and mode for all these ages. For the mean, you just have to add all these numbers and divide them by how many entries you have. So when you add all these numbers and divide them by 20 people here, you are going to have 23.8 years old will be your mean, your average age. For median, you have to list them from smallest to greatest first, which is already listed. And then you have to find a middle number. Since there are 20 entries here, we have two numbers in the middle. We have 21 and 22 right in the middle. So we need to add them up and divide them by 2. So this will be the median age. And then for mode, the most frequent number shows up in the data set is 20 years because we have 6 students who are at the age of 20, and this is the greatest number. And therefore, this is the mode of this class. Now, I have the mean listed here, I have the median listed here, and I have the mode listed here. But when we talk about the mean takes every entry into account, but it is influenced by the outlier of 65. So having one student at the age of 65, it affected our average way too much. And then although we have more students at the age of 20, now our average age is about 20, it's almost 24 years old. When we look at the median is 21.5. The median also takes every entry into account and it is not affected by the outlier. So there is no way we will know that 65 years old shows up in the class. It didn't affect our number. It didn't change our number way too much. And then mode is 20 years old. In this case, the mode exists, but it doesn't appear to represent a typical entry. So sometimes a graphical comparison can help you to decide which measure of central tendency best represents a data set. So here they have the mode, they have the median here in the middle, they have the mean here, and then this is the outlier 65, and these are the frequency, how many people you have at the age of 20, how many people you have at the age of 21, and then this is the gap between the last 20 years old one and then the 65 years old one. In this case, it appears that the median best describes the data set because when you look at the median is in the middle of mode and mean. So median is going to best describe the data set. Weighted mean. The weighted mean means the mean of a data set whose entries have varying weights. The weighted mean is given by so it's X bar, sum of the all data set entries divided by the weights, where W is the weight of each entry. So we use the weighted average a lot when we are calculating our GPA. So your grades from last semester are in the table. The grading system assigns points as follows. A is 4 points, B is 3 points, C is 2, D is 1, F is 0. So determine your grade point average, which is weighted average. So if you receive the C on a class, which is 3 credits, it's not the same effect as getting a C on a class, which has 4 credit hours. So with this table, we're going to calculate the GPA using the weighted mean. So first, if you look at the chart, we have the grades as letters A through D. And then A is 4, B is 3, C is 2, D is 1, and F is 0. So the first thing is we're changing those letter grades to correspondings. And then we're copying the credit hours for each class that we received that letter grade. So we're multiplying 2 by 3, which makes 6. 2 times 4, which makes 8. 1 times 1, which is 1. Then we're adding all these points we accumulated, which is 40 points. And then we're adding total credit hours, which is 16. So we're dividing our total points by our total credit hours. So 2.5 will be the grade point average for this table. Mean of group data. Mean of a frequency distribution approximated by this formula where X and F are the midpoints and frequencies of a class respectively. So we're going to understand what this one is with an example. Finding the mean of a frequency distribution. In words, find the midpoint of each class, which means you're going to find the lower limit of each class and the upper limit of each class. You will add them and divide them by 2. This is what finding the midpoint of each class means. Find the sum of the products of the midpoints and the frequencies. So whatever the midpoint you got, you're going to multiply it by their frequency. Find the sum of the frequencies. So you're going to add those frequencies for each class together. And then you're going to find the mean of the frequency distribution. So total sum divided by n. So here's an example we're going to look at with this chart. The frequency distribution shows the cell phone screen times in minutes for 30 adults on a recent day. Use the frequency distribution to estimate the mean screen time. Using the simple mean formula, the mean screen time is 285.5 minutes, compare this with the estimated mean. So we have the class midpoint given. So this was listed as one of the steps that we had to do, adding the lower limit of the class with the upper limit of the class and dividing it by 2. But in this example, they gave us the class midpoint, and we have the frequency for each class. So first thing we're going to do is we will multiply this class midpoint by the frequency, and then we're going to compare what is the total we have for each class. And then we're adding all these numbers to find the sigma. And then because there is total of 30 frequencies, when we divide it, this is the X bar, 287.7. So the mean screen time is 287.7 minutes. This value is an estimate because it's based on class midpoints instead of the original data set. So if you go back to question, so use the frequency distribution to estimate the mean screen time. So when they say estimate the mean screen time, we're using the class midpoints to calculate the mean. Using the sample mean formula, but they got this answer 285.5. We got 287.7, which is little over than 285. Last thing we're going to look at for this section is the shape of distributions. So we have symmetric distribution. We're going to come back and look into this. We have uniform distribution. We have left skewed, and we have right skewed distribution. So if you go back here, a vertical line can be drawn through the middle of a graph of the distribution, and the resulting halves are approximately mirror images. So when you look at this symmetric distribution, we have the highest bar in the middle, and then on the right of this highest bar and left of this highest bar, I have the same height. So this is symmetric distribution. What is very important for symmetric distribution is mean, median, and mode. They all land on the same location. This is just a perfect distribution, that mean, median, mode at the same point, and this is called symmetric distribution. Next one is the uniform distribution. You can also call it rectangular distribution. All entries or classes in the distribution have equal or approximately equal frequencies. And then it's also symmetric. So what they're saying is, so the first number 1 has a frequency of 20. The next number 2 has the frequency of 20. Next number 3 has the frequency of 20. So all of these numbers on the x-axis, they have equal or approximately equal frequencies, which gives you a rectangle shape. And then what we see on this rectangle shape is, first of all, there is no mode because all of them, they repeat the same amount, right? So if you look at this, mode has disappeared, but mean and median, they still fall into the same point. So that we lost the mode, but mean and median are at the same location. Now, left skewed distribution. So they call this as negatively skewed. So when you look at this one, we have more data points on the left side than the right side. So this is a skewed left distribution. So the tail of the graph elongates more to the left. So when you look at this graph, we have more portion of the graph. We're covering more area on the left side. And what is really important is which one comes first, which one is the last. This is the important part. The mean is to the left of the median. So here, first thing we see is the mean, and the median is in the middle. Mode is at last on this line from left to right. So mean is always left of the median for the skewed left distribution. Mean is on the left of the median. For the right skewed distribution, when we look at here, I'm going to unzoom. So this is called positively skewed distribution. The tail of the graph is on the right. If you look at this, we are covering more area on the right than on the left. This time, the mean is to the right of the median and mod shows up the first. So here we have mod, median, mean. So mean is at the end and median is in the middle. When we look at here median was still in the middle, but mod was on the, mean is on the left of the median. And then here, mean is on the right of the median. That's how we do this. And then the mode is before median and mean for these questions. That's all for 2.3.